So my topic is section 19.3, which is focusing on Ka calcs. And Ka is the acid constant, and we're going to be solving for it. Yeah. So our first practice problem is going to be page 614, number 21, which asks you to solve for the concentration of H plus given the pH. And the reason I'm starting with this one is because this is the first step in the Ka problem, so I figured kind of need to know how to do it. So you want to go from pH to the concentration of H plus. You're going to do 10 to the negative value of your pH. So in this case, that means we're going to do 10 to the negative 2.37. Your calculator 10 to the negative 2.37 is 4.3 times 10 to the negative third. So, on to the actual Ka problems. We're going to be doing page 616, number 23. Thought I wrote that down. We're going to be doing page 616, number 23, A and B. So, for A, it says that you have a 0.22 molar solution of H3ASO4 and that your pH equals 1.5. So the first thing you're going to want to do is take this and get it to your concentration of H+. So you're going to do 10 to the negative 1.5 without your calculator, which gives you 3.2 times 10 to the negative 2. So now we can start to actually do the Ka problem. So you're going to want to start by writing your equation. It's going to look like this. And you're going to take, so what you do is you start with what it gives you, your solution, and then you just take out one H plus ion. These two are equal. You're going to want to remember that. So now you're going to start and you're going to set up your icebox. You're going to fill in what you know. And these are both 0. And these are your x's. So for this, it's going to be leaning. So this one's going to be negative. And these are both going to be plus. And then you fill that in. And here's where your H plus concentration comes in. This number, 3.2 times 10 to the negative 2, is your x value. So you just plug that in. You solve this, you get 0.188. These are obviously 3.2 times 10 to the negative 2 and 3.2 times 10 to the negative 2. And so now, from there, you can use that to solve your actual Ka. To solve Ka, you take 3.2 times 10 to the negative 2, because this is your products. There's 2. These are both equal to 3.2 times 10 to the negative 2, so you're going to square that. Put that over 0.188. Solve that in your calculator, and you get 5.4 times 10 to the negative 3. Boom. So then for B, it tells you that you have a 0.04 molar solution of HClO2 and that your pH equals 1.8. So again, you start by 10 to the negative 1.8, calculator, which gives you 1.6 times 10 to the negative 2. Set up your equation again, taking out that H plus, And your icebox one more time. Fill in what you know. These are again both going to be 0. Your x's for these ones are going to be the same. You plug that in. 0.04 minus x, x, and x. And again, this number, your hydrogen concentration, is going to be equal to x. Well, it's going to be equal to x. And these two are both equal. So we have 1.6 times 10 to the negative 2, 1.6 times 10 to the negative 2. Plug this in. Oh. I don't know why that got dark. Oh. Plug that in, and you get 0.024. And then we can again solve for Ka. So you're going to go 1.6 times 10 to the negative 2. Squaring again because both of these are equal. Put that over 0.024. You get your answer of, get your answer of 1.1 times 10 to the negative 2. And that's how you do Ka calcs.